All right, welcome back, everyone. So we are, here for the Motoko session on data structure. I'll wait a few minutes for everyone to join. I think the fact that we changed the meeting confused some people. I needed to do that for the recording. Okay, well, let's get started. So we are here to talk about data structures in Motoko. So important thing is that we start with a clean project. We have, where is my terminal? So we have a main.motoko file, and I will create a defix.json where I will have my canisters listed, and I'll call this canister data structures. Just give it a simple name. Then the main file, which is going to be main.mo, of course. And the type of the canister is Motoko. And that's everything we need. I can zoom out a bit. We don't need more. So that's about it. That's the agenda for today. So we'll talk about arrays, share types, buffer, list, hash map, and tree map. Actually, we've already talked about array and buffer a bit, but we'll talk again about it. So how do we store data in Motoko? Well, we've already seen variables, so let and var. But now I want to talk about data structures. So how do we organize data? And which data structure should we choose? What are the limitations of the array over the buffer, over the list? And how do I navigate that? So first thing first, I want to make it clear, I'm talking about data structures that are parts of the Motoko base library. So, because those are like basic things. When I say basic, I don't mean it that it's necessarily simple. It's just that it's part of the base library in the sense that it's part of this list. So this list here contains the base library. So you have array, as you can see, a buffer here, hash map, we'll talk about it, list, we'll talk about it, and tree map, we'll talk about it. Of course, there are more data structures and other types. For example, there is the text. We've already seen this one. There is the NAT, and a few more things, but essentially today I'm talking only about data structures that are parts of the Motoko base library. The base library is a library that is maintained by Dfinity and is, I would say, part of the language itself, because you can import it easily. You don't have to have a package manager, and it's packed with Motoko. Now, there are other data structures, which we might talk about later if we have time, but it's not the priority for this week. Those other data structures are coming from mops. So mops is a package manager from Motoko. We haven't used it and we will not use it before the end of the week, but essentially you have packages published here and, well, let me see. And you have a ton of data structures. So for example, stable heap B3, augmented B3s, map, vector, linked list, circular buffer, a lot of different libraries and a lot of data structures. But this is more advanced, I would say, and won't talk about that today. Okay. So how do we define an array? How to define an array? Let's say there are students, and this will be like students from the bootcamp. And I'm going to give it some names. So we have Alex. We have Daniel. We have Dennis. Who else do we have? And Victor. Okay, so that's how we define an array in Motoko. Important to understand that an array in Motoko is typed. So Motoko, again, is a typed language, which means that all the elements here should be of the same type. We can actually specify that here. I can say that this is an array of type text. And oops, yeah. And that's how we define one array. So we can use that, for example, in a query function, get students. And we can return the array simply by doing return students. It's async, of course. So let me deploy that and see how it looks. Let's say dfx start. So I'm starting a local replica. And dfx deploy. So, oops. Yeah, I think it didn't start. Yeah, okay, I needed to wait for it to be really start. So start it. So that's should be good now. When you run dfx deploy without specifying the name of the canister, it's going to deploy all canisters that are listed in your dfx.json. So in my case, I have only one. So it would be exactly the same to do dfx deploy data structures or dfx deploy. Okay, and now we can access the Candid UI, so the interface of our canister. We have one method, and we can see that we have the array. So this is displayed from the Candid types. So essentially, those are the vec that you see corresponds to an array. The vec is a Candid type. So Candid is this interface description language. It's the way that canisters communicate with each other, because you can have a canister in Rust communicating with a canister in Motoko, communicating with a canister in TypeScript, and so on. And for that, we need a common language. The common language is called Candid. So here, it's not Motoko that you see, it's actually Candid. And so an array in Motoko is a vec in Candid. So that's why you see this vec. Okay, so that's immutable array. Why? Because we cannot do something like this. It wouldn't work. So let's say I want to change a student. I want to create a function called change student. And I give it two parameters, index, so the index of the student in the list, and the new name that I want. So essentially, this function would do students index would be replaced by the new name. So we could do it like this. expected mutable assignment target. So this is not mutable. Even though we have a var here, the var means that we could replace the array. So we could do like students is equal to, yeah, like this one would work. But changing one element, like by targeting the index, like you can do in, other languages like Python, you can do that. JavaScript, you can do that. It doesn't work in Motoko because this is an immutable array. What is a mutable array? So we can do students mutable, and this is going to be a different type. It's a completely different type because it's a var text. And then you need to specify var. And then actually we only need the first one. Then it's implicit because all the others are going to be var as well. You can only do like either everything is a var or nothing is a var. And for this one, we can actually do it. Just need to replace that. And then it works. Now, I want to talk about something which you are not going to like. And I actually had a lot of issues with that when I started Motoko. This error, shared function as non-shared return type var text, type var text is or contains non-shared type variable text. What does it mean? So if you're like me, it doesn't seem very clear. And it's actually very annoying. This is because in Motoko, only shared object can be return arguments or return values of a shared function. So what is a shared function? I had this question yesterday. Any public function is a shared function. So we can actually put this shared function, this shared keyword, here, or we can remove it because by default, it's implicit that if it's a public function, it's a shared function. Because a shared function is a function that can be called by other actors or other users. So it can be called by a user, so it can be called by any other entity in the system. And shared function cannot use non-shared return type. Why is this a non-shared return type? So actually imagine, I think the best way to understand it is to imagine what it would mean if we could share this object. Imagine that you can send that to another canister, like this list of mutable students. You can send that to another canister without any problem. What is going to happen is that if you share this object, because it's a mutable object, the other canister would be able to change any field here. So imagine if you are developing an application and you can share your data structures around multiple canisters, and those canisters, they can modify the data structure without you knowing about it. Imagine the mess that it would be. It would be impossible to know for sure that you haven't shared it with like other canisters and they are not doing modification, adding students, removing students at the same time that you are doing it. So it would be a complete mess. And that's why you can only share objects that are mutable. Like this one you can share, but not this one. So this is the second concept I wanted to talk about today. It's this concept of shared types. And it applies to a lot of types. Like, for example, buffer cannot be shared directly. And all the shared, non-shared types cannot be shared. So how do you do if you want to have a function that returns what is inside this array? You need to use something called array.freeze, which essentially is going to convert your mutable array to an immutable array. So I have it open here. This is the array module, and not the second, but it's pretty high in the list. It's called array.freeze, transforms a mutable array into an immutable array. So the parameter is variable array, and it returns an array, a normal array, I would say. So we can try it. Return array.freeze. And we need to import the array module. Ah, it's already out there here. And so we have this concept of generic. The generic type is the type that you see here. So this function freeze is actually can be used, of course, for any type of array that you can think about, like whether it's an array of text or natural numbers or booleans or character. But you need to specify every time you use the function, you need to specify what is the type inside this array. And so this is going to be text in our case. So of course, we need to remove that because now it's going to be an array of text. And we can try that now. So let's see, get students mutable. So we have Alex, Daniel, Denis, and Victor, and I'm going to change the student number 2. So it's actually Denis because this one is 0, 1, and 2. And I'll put my name. And then query again, and you can see that it has been modified. So it seems to work. So that's all about arrays. We have already talked about the fact that arrays are not very good for adding elements. So we can use array.happen, but array.happen is going to create a new array by copying the value from the array 1 and the array 2. So it's not a good complexity. If you are adding a lot of elements, you want to consider the buffer. So let's move to the buffer. And it will be number 3, buffer. We need to import the buffer from the base library. So the buffer is a class. Actually, we can take a look at it. So it's interesting if we look at the Motoko, Motoko library. So GitHub Motoko base library. This is the code for the Motoko base library, and we can go into source. And you can actually take a look at how those modules have been coded. And if you look at buffer, you will notice that buffer is a class, public class buffer, and then it's the entire logic of the buffer is defined here. So we are not going to explain everything, of course, but every function that you see has been defined here. And this is the case, like you can take a look at array. So array is not a class, it's different. You can take a look at how hash map are defined and so on. So because buffer is a class, when you define a buffer, you need to use the buffer library and the buffer class. So I'm importing the buffer class from the buffer library. And you need to specify what you're going to store in the buffer. So in my case, it's going to be text. And the initial capacity, you can set 0 because it's always automatically going to grow whenever you need it. So I'll name that student buffers. Do you think I can just share the buffer so we can try? This is of type buffer.buffer of text. So this is the type of this variable, this one. And let me show you what happened if I do that. And I just return students buffer. Of course, it's the same error that I talked about earlier. So shared function has non-shared return type. Buffer, and then it lists all the methods that exist on the buffer. Type buffer is non-shared type. Every class in Motoko is non-shareable. That makes a lot of sense because the buffer actually, if you would be able to share the buffer to other canisters, they could just add element into it by doing buffer.add, and you wouldn't like this because that would be a mess. So I see some people in the chat are confused by this concept of shared. I'll explain it once again. The shared concept. So when you say shared, it means that other actors, so other canisters or other users, are able to call this function. What is the difference with public? So actually, it doesn't make any difference when you are in a situation like this, because every public function in this file is going to be a shared function by default. It's not the case if you have a module. So that's why we haven't seen the situation yet, but we will see it later in the bootcamp. But you can have, instead of having an actor, so instead of having the actor keyword here, you can have the module keyword. And the module keyword is going to be used when you want to create modules. So modules are functions that piece of code that you can reuse. So maybe you want a module for like utilities function. Maybe you want a module for certain functionalities of your application. And that's how you define them. And then when you have a public function here, so you can also have a public function in a module, it only means that it's public when you import, like import utils. So this is going to be utils like this. It only means that you can import like you can import this function. If it's private, then of course you are not able to import it. Field foo does not exist. So in the context of a module, public means accessible by other, like accessible by other modules. So accessible here or by other modules. But it's not accessible from the outside world, like outside of the canister, other canisters, users. Even if here it's defined as public, as long as it's not in the body of the actor, so in this file, the main file, it wouldn't be accessible to outsiders. Only like this, so only if you do something public here. So then it becomes accessible. But if you don't do that, it's not because it's public here that it's accessible by external users. And essentially, there is no difference, like when it's in the body of an actor, every public function here is gonna be shared. So we could have it everywhere, or we could just not have it because it's the same. Now, why do we have those concept of shared types? So for every shared function, you can only have shared return types. So the return type is here, this one. Well, it's asynchronous, but it's always asynchronous. But this one is a shared type. This one is a shared type. This one is not. How do we know what is a shared type and what is not? It's pretty simple. Like every class in Motoko is not a shared type, and every mutable variable is not shareable. Because if you think about it, imagine that you can share your mutable variables with other canisters. Then you don't control your code anymore, because it means that your variables would be all over the place and other canisters would be able to modify it at any point without you being aware of it. That would be super dangerous. And if we were to program like this, we would have crazy tons of errors. So it's not the case. So how do you do? Well, you have to always convert whatever variable you're trying to share with a shareable variable at a shareable type at the moment you want to share. So you can have a buffer, but then if you want to share it, you can only share the array of that buffer. So you would need to convert that to an array. It's kind of like if you were taking a snapshot of the variable and you share that outside of the world, but you don't share the actual variable itself. You only share like a representation. So we can try that. Public function add students to the buffer. Oops, so students buffer.add. And we can try to deploy. Okay. Let's see. So this is our buffer. It's currently empty and we can add a student. So let's say we add Alex, we add Daniel. And now we want to see our buffer, and that's it. We have Alex and we have Daniel. So that seems to work. There is not too much to say about buffer. It's a very complete class. So you have everything that you need. Like you can do buffer.size. It will give you how many elements are inside the buffer. You can do buffer.get, buffer.put. You have all those functions, and I'm not going to like make an example and try all of them. If you know how to use, if you know how to define a buffer and how to use, like how to do what I've done here, well, then it's just about reading the library and making use of what you need when you need it. The important function, I think, is really this array to array, because you will very often convert your buffer to an array or convert an array to a buffer. So those ones are pretty important. Okay, so that was concept number. So we've done that. Done. We've done the array. We've talked about the share types. We've talked about the buffer. Now I want to talk quickly about the list. I don't use list a lot, to be honest. And also it's not the easiest type when you are starting out with Motoko. Why? Because it's a recursive and also functional type. Essentially, because type is a list is defined like this. So a list is defined by a tuple of elements, which is one element. Like let's say you have a list of nat, it's going to be defined by a tuple of a nat and a list of nat. And whenever this, well, optional, so this is like optional here. Whenever this is null, so whenever this is over, it's the end of the list. So how do you define a list? You create an empty list like this. So list.nil, we can do it. Let's say variable student list. It's gonna be a list. We need to import list. is going to be a list of, why is it unbounded? I need to, yeah, okay. We need to import the type list from the type, like, yeah, we need to import the type list from the list module, same as buffer. Well, actually that starts to be like a bit, it's, yep. We could get away with this syntax by doing this. So what I'm doing here is a trick that you can use to simplify most of your, like to simplify how you write things. We could do it for buffer. If I do buffer here, public type buffer is equal buffer.buffer and public type list is equal list.list. What I'm doing here is that I'm importing the type list for any type, like any list, if it's a list of nuts or text or Boolean, whatever. I'm doing an import and I'm importing the list module, or yeah, the list module, the list object from the list module. So that way I don't have to repeat myself after like every time I'm doing an import. I can just define like this. And that's cleaner. And you can do exactly the same for buffer. For example, here, we could just do that. Okay. So if I want to add a student to a list, something we can do, and we can do it by using list.push, which is going to add an element at the end of the list, and then return the new list. So that's slightly different than what we've been used to, because with a list, we actually need to store the result in a variable and use the function. So like, let me show you, like list dot, we need to do let new list. So the new list is going to be student list, list dot push. So list dot push. The first argument is the element we want to push. The second argument is the list we want to push the element inside. So it's going to be name here and students list. So that's our new list, and then we need to assign the new list to our variable. Finally, if we want to get the student list, again, we cannot share a list because it's not a shareable type. So I can try if you want, just for the record. It's public query function. Oh, sorry, I misunderstood something. It's yeah, it's a shareable type. It's a shareable type. What's happening here is that even though we have a variable here, it's not going to share the reference of the variable. It's only going to share the value of the variable here. So it's like taking a snapshot, and it's a shareable type in that case. And yeah, we can deploy that. So my list is currently empty. If I add a student to the list, then I can see the new list. So it works. Okay, so that's about it for list. Then, of course, you have all those methods. You can push, you can get the last element of the list, you can pop element from the list. So list is going to be very good for adding elements, but not so good for finding elements, because when you want to find elements in a list, it's essentially the opposite of an array. You have to go through the entire list. So yeah, that's what they've written here. Get is not super efficient. Indexing it to a list is a linear operation and indicates that it might not be the best data structure to use. Can you list through a list? Yes, you can. You can list through an array as well. Actually, we haven't done it, but so maybe I should talk about that. Yeah, I should maybe talk about that after. So we have talked about lists. Now I want to talk about hash map, and I think tree map will be for another time. Hash map is super important in the sense that I think it's one of the data structure that I've used the most in Motoko, simply because it's very complete, and like, yeah, it's a very complete and balanced data structure. So it has kind of the best of both worlds. It's very good to access. It's very good to put elements inside. And you can very easily like do like a data member, like a member database, or like any kind of application where you need to store, put things, get things with a hash map. So we need to import it, hash map. How to define an hash map. So for those of you that are not familiar with what is a hash map or a map is a data structure where you associate keys with values. So here the keys are going to be of type type key, and the values are going to be of type value. So one example of that would be let students hash map, or maybe we would have like a let variable students ID. So we would have an ID for each student that starts maybe at 0. And then we would have a map that associates student ID with their name. So text. The idea is that there will be student number 0, student number 1, number 2, and so on. And we can easily access the students like this. So to build a hash map, this is the arguments that you need to specify. You need to specify the initial capacity. Again, we can specify, just like the buffer, we can put 0 because it's automatically going to grow. And then we need two functions, a function that takes two keys. So for example, in our case, a function that takes two natural number and returns a Boolean that indicates if those keys are equal. I'll explain how we find this function later. And then we have to find a hash function. The hash function takes a key and returns the hash of the key. So I don't want to make it a computer science like degree or course here. If you don't know what is a hash map and why we need those functions, then you have plenty of videos. I can provide some links that explains that how a hash map is essentially created and structured. For Motoko, we need to specify those two functions. So we are going to take a look at the NAT library because we have keys of type NAT. So that's why I'm going here. And there is a function called nat.equal, which is pretty basic, but it's what we need. It takes two natural number, x and y, and it returns a Boolean indicating if x is equal to y. And it's essentially equivalent to doing x equal y. For example, not equal 1, 1 would return true. The reason why this function is defined in this library is that you can use it as a function value to pass to a higher order function. So that's essentially what we are doing here. So I'm going to pass it here, not dot equal. And then, so, oops. I will need to import the not library. So that's it for the first one. And the second one is the hash function. So maybe we could think it would be not.hash. Unfortunately, there is no hash function defined here. It would be great if there was one. We could use it, but it's not. And so we need to use like this one from the hash module. So actually a hash is just nat32. And so we haven't seen that yet, but we have this concept of nat8, nat16, nat32, nat64. Those are essentially also natural numbers, just like this one of type nat. So this one is of type nat, by the way. But the type nat is unbounded. So it means it has no limitation in terms of how big the number can grow. Nat8s are limited. So those are like 8-bit numbers. This one is 16-bit, this one is 32 bits, 64 bits. So those ones, you generally don't use them a lot, except for a few like cases where you really want to play with the bits, individual bits. And of course for the hash. So hash is a nat32. And so the one we need is hash.hash, which takes a natural number and returns the hash. And hash.hash you will see that this function is deprecated. Usually when you see this deprecated, there are a few functions. I can see, for example, in the comments, someone asked the question about array, like buffer.toArray, because there is like a few deprecated methods. This is because Motoko is going through changes, and those are functions that are modified. So this is going to be case by case. Like some deprecated functions are totally fine to use. For example, this one is totally fine to use as long as our key doesn't grow that much. Like if we get into the millions millions of users, this would start to be an issue. But for this example and for most cases, it's totally fine. There are other deprecated functions that I really recommend to like not use. For example, array.happen is really not a good function to use, and a few others. It's not going to be the case forever. Like I hope that some days they can remove those deprecated functions, like, or at least replace them, because it's a bit annoying, but yeah. Okay, so we have our first hash map ever. So that's great. And now we can do some things, like we can do public function add a student, so a name, and then we return nothing, so we just add it. What I'm going to do is good job to ChatGPT, so to Copilot. That's exactly what I was looking for. So students hashmap.put. Hashmap is also a class, just like buffer was. And so we have the .put method, which is here. And essentially .put, we specify a key and a value. So the key is going to be the student ID, and the value is going to be the name of the student. So this is a nat, and this is and this is a text. And it's going to put that inside the hash map. And then we want to increase our ID by 1, so we just do that. And then we return. Now I can do get students, and well, that's not what I want to do. Yeah. Index of type nuts, and then so this dot get is going to return the student that is stored at the index that I provide. And here I need to specify optional. So this is optional. It's not text, it's optional text because we have this interrogation mark. What is an optional type? Well, an optional type is going to be either the type here or the null value. So the null value is this one. It exists in Motoko to represent the absence of value, actually. So why do we need that? Because imagine that we specify an index that is like, I don't know, 100, and we don't have any students at this index, then this is going to return the null value. So I can show you here, when we do .get, returns the value associated with the key, if present, and null otherwise. So that's why we need this optional type. Now let's do a test. So you need to refresh that. And we start to have quite a few good amount of function. So right now we don't have any student in the hash map. So probably if I look, it's going to return null, of course, even for like any index. But if I add a student, so add student to the, I think it's, yeah, it's this one. This is going to add a student to the hash map. So it starts with the ID 0, and then it's going to increment. Let's say Daniel. So Daniel should be at index 0. Then we can have Victor at index 1. And so now if I take a look here, 0, Daniel, and 1, Victor. And then 2, there should be no one. So that seems to work. The hash map has a few more functions. Like, for example, we can have the size, which returns the number of entries in the hash map. And we can have replace, we can have delete, remove, keys, which enables us to iterate over the map. Values iterates over the values of the map, entries over the entries. We have a few, few of this iter function, which I will talk about in another session. We are now at, we are almost at half the hour. So I will stop here for today. We have covered everything I wanted to cover. For the project number 2, so we were going to do it this afternoon. We will use the hash map for the first time. So I'll go over it again. And there are a few more things, like there are way more things I want to talk about all those data structures and how to choose them, how to use them, how to iterate over them, and so on. But that's already a good start. Keep in mind this difference between immutable and mutable array. Keep in mind that buffer is a class as well as hash map. So they cannot be shared outside of the world, but you can use them totally, like you can totally use them. And then keep in mind this idea of shared type that we had here. Then if you have a question, you can take a look at the documentation. You can also ask me a question. And we have 5 minutes remaining, so I'll just take a look at the chat I've seen a lot of questions. I'm sorry, I didn't want to stop before the end of the hour because I had a lot of things to go over. So yes, I will add the solution of project 4 to project 5. So Daniel, how do I change my Gitpod? Actually, I don't know. You should be able to do it on your side. And for the extensions, you have the Motoko extension in the Gitpod already by default. If you're looking to have GitHub Copilot in your Gitpod, I don't think it will be possible because actually this is something you have to pay for. So I pay for it on my machine, but not on Gitpod. Is HashMap the same as a dictionary? Yes, similar to a dictionary in other languages. How do you best implement a custom hash? Well, it depends on which type. So the hash is going to depend on the type that you have. So if you have a keys of type NAT or text or Boolean or a custom type, this is going to define which hash function is going to be the best. I don't have an answer for that, but you can, yeah, it basically depends. Like you should have, you should look at on the internet. I think there are videos and resources on how to create a good custom hash function. And yeah, actually someone answered the question. There are various hashing algorithms online. Yeah, you want to minimize the amount of collision. Who controls or administers ICP? Is there a company? No, that's the whole point of ICP. There is no company that manages the network. That's the whole and entire purpose of ICP. Right now, you could say that Dfinity has a lot of impact and influence on the network, and that's true. But that's not the end goal of the project. The end goal is to have a system that is completely decentralized. So yeah. What does nat.equal do? Well, nat.equal here takes two natural number and returns a Boolean indicating if the numbers are equal. So if you have 1 and 1, it's going to be true. If you have 1 and 2, it's going to be false. Apart from public and private, do we have anything else like protected? Can an actor inherit other actors? You can create classes of actors. So you can have like canisters that are created from a class and you can replicate that. But I'm not sure I understand the question totally. Like, what do you mean by protected? By default, the data that is in your canister is only accessible to your canister, except if you make it public through functions. Why do you need that when defining a hash? This is because of how the hash map is defined. So this is how you define a hash map. You need three things. You need the initial capacity, which you can set to 0 because it's always going to grow whenever you add elements into the hash map. It's always going to grow as needed. So you can start with 0. Then you need to specify a function that takes the keys and returns an equality between the keys. And that's why we need this function. And then you need the hash function. And that's why we have the hash.hash. In the hash map, can we have duplicate keys or values? No, so like each key is associated with one value. So like the key number 0 is associated with one name. The key number 1 is associated with one name and only one. But you can have, like, we could have students with the same name, like we could have multiple times the name Victor, for example, could be multiple times in the hash map, but not with the same key. So like we'd have a key number 2, key number 3, and so on. Yeah. Yeah, I will upload this video and I will upload with the useful links. So all the links that I've used from the documentation as well. Could you please give example on each code comment of like what it's most noob friendly in real function? Hope it makes sense on what I wrote. No, it didn't really make sense. Like, do you want comments from the terminal, like the fx command, or do you want command in Motoko? Like, you want more example of code like this? Okay, yeah, Motoko. Yeah, of course, more Motoko example. I'm working on a course right now, so like I'm working on more videos, and by the end of this month, so January, I should be ready to publish it with like very simple examples and starting from zero. Essentially what I'm doing here, but in video and with more preparation and more examples. So yeah, don't forget that you also have the chapters in the I know that not a lot of people look at it, but you have like in the repository you have chapters, and chapters like let's say chapter 3, for example, you have a few examples of code in Motoko, which is really, really useful. So yeah, you can take a look at essentially chapter 1 to chapter 5. You have a lot of smaller example. Okay. So yeah, thanks for letting me know that the links are broken, some of them. I need to check that. Okay. Okay, I'm hyped for that. Yeah, I'm also hyped. Cool. I hope that gives you some boost. Yeah, it's not easy, but if you take your time, you will make it. Okay, so that's it for today or for this session. I will see you in 1.5 hours. We have project number 2 to build together, and until then, keep building and see you guys.